Hi math colleagues, and thank you for watching this video where we will be going through some authentic performance task examples in math. The first thing I want to say is thank you. It is a privilege to work with such dedicated educators who love their students and want them to grow not only academically, but emotionally and socially as well. The second thing I want to say is that I hope this video is, if not a reminder or a refresher on the good work that you're already doing in your classes, I hope this is a confirmation that what we are trying to do for our students is reflecting work that you're already doing in your classes. So, with that in mind, let's get started. So the first thing I want to highlight are some of the characteristics that we've defined for authentic performance tasks. And this comes from the committee that met last winter. And I want to highlight that first bullet point. Their authentic performance tasks allow for students to transfer their knowledge to a new situation. If I'm studying to be a mechanic, I can read all the texts and resources I want on different models of cars and parts of cars and processes to fix particular problems. But I'm not really going to be able to fully be a mechanic until someone brings a car in that has a problem and I can actually put my knowledge to use, that I can apply my learning to a new situation. That's how you become a good mechanic. And we want to create these same situations for our students where they can apply their knowledge to a new situation. Now, there are two particular strategies that teachers can use to help frame the creation of authentic performance tasks. And this example comes from Wiggins and McTighe, and they use an acronym called GRASP. And if you can answer and describe each of these components of an authentic performance task, then you have one. The first is goal. So what is the challenge or problem that the students are going to overcome? Again, using the example of a mechanic, what's the problem? Is the check engine light on? Does the car not start? Are the wheels not aligned? Is there a strange sound coming from it? What's the problem? R is for role. What role is the student taking? Because a particular role that a student will have in a problem will frame how they respond to it. For example, using the mechanic problem I just gave, if you're looking at a car that has a check engine light on, are you the mechanic or are you the person bringing the car in? That's going to reframe what you're going to be asked to do. In terms of A, who's the audience for this? It could be professionals in the community. It could be administration. It could be teachers, peers, or other students at school. What's the situation? And this provides the context for the problem. So if the challenge in a mechanics example is to diagnose and fix the problem for a car, the context or situation should be someone brings in a car, they say it won't start, they say they changed the battery, and nothing's working. P is the product. What are they actually making at the end of this authentic performance task? What data are they gathering and publishing? Now that could be finding survey data and using that data to answer different things about information with other students at the school. This could be podcasts, video production, experiential learning, infographics. What are students actually going to be making at the end of this? And S is for standard. So how is this actually going to be graded? And what is the grading tool that's going to be used? Now that depends on the standard. We could have multi-proficiency rubrics, we could have single proficiency rubrics, or we could have checklists, depending on what that rubric is asking. Another way to frame authentic performance tasks, and we already do this in our minds as we prepare for units, is this particular graphic organizer, which I think does a great job in looking at the different mental steps that we take as educators. So on the left side, we have a particular outcome, and this is for an economics course. Students will understand that price is a function of supply and demand. Well, the next step I have to think about is what kind of thinking students need to demonstrate to show this learning. And this can be separated into simple understanding issues like explain, and higher order thinking skills like interpretation and application. Once we're able to understand and catalog the types of thinking students are going to be needing to demonstrate, we can then align that with an assessment that will show us that they're doing that kind of thinking. Now, those simple understanding processes would be my formative assessments. This lets me know that they have the knowledge for a particular concept. And these higher order thinking skills would be my summative assessments, because this would be the application of that knowledge I've already assessed. Well, with that in mind, let's take a look at a couple of examples. Now, where can you get these? In the BFS curriculum folder that I shared in my email, and I also shared last year, you can go to UBD exemplars and Stage 2 exemplars. Now, I've divided this into different disciplines, so you want to go to the math folder, and then I've divided further into different divisions, so elementary, middle, and high. What I want to do is look at one example of elementary, one example of middle, and one example of high school, where you can take a look at these. So the first thing we're going to do is take a look at elementary school, and this is going to be, let's look at example 3 in elementary school. This is looking at geometry and measurement. So we have our objective here: solve real-world and mathematical problems involving perimeters of polygons, including finding the perimeter given the side lengths, finding an unknown side length, and exhibiting rectangles with the same perimeter and different areas, or with the same and different perimeters. So I love how they take the GRASP acronym and apply it to the sentence. You're a scientist, there's the role, who wants to design a unique designer pet. So that's the challenge. To be a companion for lonely social distancers. So there's our audience. Prepare a visual of the perfect pet using graph paper and your knowledge of perimeter and area. So that's what they're actually doing. Now, in terms of this next section, they have the parameters of what they're going to be looking for in the assessment. And here is a rubric that they used. Now, if you had worked with this teacher, you're going to find that similar assessments like this are going to have very similar rubrics. This rubric is a great basis because it can be applied to multiple situations, and it provides clear guidelines for students. Now, if you notice, the first part of this assessment starts off with basic mathematical process questions. And this is going to let students and the teacher know if they have progressed past these two proficiency areas. So before you can apply your knowledge, you need to assess if students can actually do that mathematical process. So here's a couple of math problems on that first page. Gets a little bit more complicated on that second page, and here's the actual application making that pet. So there are the questions, and there's the graph paper for that. So that is a great example of an authentic performance task for elementary school math. Let's take a look at middle school math. So this is example 4 in the middle school math folder. Now, what I really like about this particular example is the application and use of the school to gather data, to analyze it, evaluate it, and reflect on it. Now, in terms of the objective, we see students will gather data through a survey and use the survey data to make graphical displays and answer questions. Now, the question is looking about how many hours you use a device on a typical weekday and on a typical weekend. And I really like how these questions are divided into different proficiencies. So here we have just the calculations. Can you work with this actual data? More simple understanding questions. And this could be used for basic proficiency. Can students do the mathematical computation that you've been learning in this unit? Then we get to analysis. Now that you've been able to calculate and do the mathematical processes, let's see if we can make meaning out of the data that we gather. So now we're going to more of those higher order thinking skills, which would go to higher proficiencies in terms of a rubric. And then we have some extension, which gets you to an even higher level of proficiency. What I also really like about the end of this assessment is the reflection section, where we're not just thinking about have students been able to show their learning? Are they reflecting on that process? Are they thinking about what went well, what needs to go well? Are they developing that metacognition that's going to help them be successful and shift the ownership of learning from the teacher to themselves? Great example. In terms of high school, let's look at performance task example 1. And I believe this is coming from the example 3 folder. Yes, it is. Now, what I really like this is for Algebra 2, and if you want to, you can pause the video and take a look at this. What this is allowing students to do is use polynomials to connect and reflect on themselves. Not only do they need to identify that, but are going to need to be able to find different characteristics of those polynomials. Now, there's a second part of this. It's just one thing if you can do that, but now they need to create some sort of product. So this is using some sort of presentation of that to better reflect yourself. And if you want to look at a little more, there's a blog down here that goes into a little bit more detail. Now again, if we're looking at the task, we're going to create, characterize, graph, and present a polynomial function that reflects you. So we use birthdays. We are creating it, characterizing it, and presenting it through this presentation. So all of these are ways that students are enacting or interacting with mathematical data and mathematical thought processes, trying to use either real-world data or trying to use a real-world situation and a challenge that can be approached in multiple different ways. If you have any questions or need any clarity on things, if you have any assessments that you're working on this summer as you're reflecting on and reviewing your classes for next year, please send it over to me. Please let me know. I want to be a resource that can best equip you with whatever you need to meet the needs of your students. Thanks for watching. Have a great day.